Hello grade 12s, welcome back to another video. So in today's video we will be doing the mathematics paper 1, November 2016, 150 marks, 3 hours a paper. It is downloaded from the Department of Basic Education website, so you can download this question paper for yourself. This question paper will have 2 parts, so it will be part 1 and then a part 2. So we will just be doing question 1 up to question 6. So meaning we'll just be covering functions, all functions questions. We will cover your patterns, series and sequences, and then we will also cover algebra and exponents. So without wasting any of your time, let's get into this paper. Don't forget to like, comment, and subscribe to the channel. And if you haven't checked out the previous grade 12 videos, please do so. I have done English First Additional Language Paper 3, English Home Language Paper 3, how to answer your SE questions, and your transactional texts. So you can check those videos. They are already live. So this question paper consists of 12 questions. Answer all the questions and number the answers correctly according to the numbering system used in this question paper. So it's very important that you read your instructions and information before you answer your question paper and make sure that you understand all of them. Now, here we are, and we are about to solve for x. All right, so guys, when we have anything like x into x, let's say minus 2 equals to 0, this x is equals to 0 always. Okay, this is a bracket, so this x here will always be equals to 0. And then with this one in the bracket, because you need 2 x values, you will say x minus 2 equals to 0. Then x will equals to 2. So this 2 goes this side. And when you change the side of any number or variable alphabets like x, y, z, they change the sign. So this 2 was negative. When it comes this side, it becomes a positive 2, and hence x equals to 2. Okay, so if you do not know your basic maths, then I'm here to help you know. So with this one here, we will just say x equals to 0, and then x minus 7 equals to 0. So which means x equals to 7. So we have x equals to 0 and x equals to 7 for 1.1.1. That's how you do this. Okay, don't confuse yourself. Don't try to solve or anything of that nature if you are given this type of question. Just do this and you are done. You don't have to use quadratic formulas, expand, multiply this x's, this x times x, and then x times this. You don't have to do all that. And this is how you get your answer. So 1.1.2, you are given this, and whenever they say correct to 2 decimal place, even if they don't say correct to 2 decimal place, in grade 12, all your quadratic equations, whether you are dealing with functions or you are in algebra, you will be able to make use of your formula. What is that formula? Is the quadratic formula. So let's go down. At the bottom, you have an information sheet here. So this is where you will find your formula. Oh, it's the first one. This one. Make use of this formula whenever you see quadratic equation to find x values. Okay, especially if you do not know how to factorize. If you know how to factorize, good. But if you don't know how to factorize, always use this sorry, formula to help you be able to answer any of those questions. You will see how you can also use it, and nobody knows that you used it. Even your teacher will think you know how to factorize, but you actually used the formula. But here, because it says correct to 2 decimal places, I cannot factorize. I have to use the formula because I am going to get decimals as my answers. So we have x squared minus 6x plus 2 equals to 0. Any number here, in this case, we have 1 here. If there's nothing here, it means there is 1. It's 1x squared. Okay, it's 1x squared. If we have the like this is 2x squared. So here we have 6. So this is a, this number here, it's a, this is b, and this is c. So it's like a x squared minus bx plus c. Okay, which is what? The quadratic equation. So we have, the formula says negative b plus or minus square root of b squared minus 4ac all over 2a. So this is the formula. What did I say? We said so we will say negative. We are substituting negative, we substitute with brackets always. So we put this b is negative 6. So a equals to a, b equals to negative 6, and then c equals to 2. So we'll do negative 6 plus or minus negative 6 squared minus 4 into a is 1, and then c is 2. This is the c, and then all of that. Yeah, oh, I made, yeah, but you know the formula, so I'm just going to erase this because we don't have space, and then we'll have 2 into 1 like that. And then firstly, with this one, you start with saying first, maybe you would say plus here, and then that's when you will get that x equals to 5 comma 6 4 5. You have to correct to 2 decimal places, so you see 2 decimal places, so it's 6,45. So if the answer after the 2 decimal places, which are this one, the number is 5, 6, 7, 8, or 9, this number goes up 1. So it's like 4 plus 1. Okay, so we will have 6.5. But if it was 4 and 3 or 2 or 1 or 0, the 4 would still remain the same. Okay, and then you would change this and make it a minus. Then you will see that x equals to 0,35. So the number after here, it's smaller than 5, so we don't have to round off. So that is how you will do 1.1.2. I hope you got that. So with this one, x is equals to 5,65, and then x equals to 0,35. Okay, so that is how you do that question. Now let's go to 1.1.3. We have x minus 1. Let's change to black color. We have x minus 1 plus the 1. The 1 is out or outside the square root, equals to x. So this is what you get. So we need to solve for x. What you do, you take this one to the side, okay? So that will be equal x minus 1. This one was positive. When it comes this side, it becomes negative, okay? So we are here. We have x minus 1 equals to x minus 1. Whoa, it's tricky. So we have to get rid of the square root, okay? How do you get rid of it? You just square like this. You just put brackets and square this, and then you also square this whole thing. So this and this will cancel each other, and then when they have cancelled each other, here you have x minus 1 and then equals to x minus 1 and x minus 1, like that. So you will have x minus 1 equals to x multiplied by x. This is 1, this is 1. So 1 multiplied by 1 is 1. X multiplied by x. When the bases are the same, you add the exponent. So this is to the power of 1, this is to the power of 1. So you will have x squared. Okay? And yeah, this is x squared. And then x multiplied by negative 1. So it's like 1 multiplied by negative 1. And that will be negative 1. And then negative 1 multiplied by this negative 1 here is negative 1. And then you leave the x. So negative 1x. So with this one, you just have negative 1 multiplied by negative 1. That will be negative 1. And then you leave the x. Negative 1 multiplied by negative 1. And that will give you a positive 1. The negatives will cancel each other. Okay? So we are here. We have this quadratic. So we'll say x minus 1 equal, let's say, we'll just say 0 equals to x 0 equals to x squared minus 1 x minus 1x plus 1. And so 0 will be equals to x squared, and then negative 1 minus 1, that gives us negative 2x plus 1. So here we can solve for x. We have the quadratic equation. So if you put this in the formula, it will give you that, for that quadratic formula, it will give you that x equals to 2 when you add, and it will also give you x equals to 1. So what you do for no one has to know that you didn't factorize, so you just do it like this, and then this is where you will have your x. This x will represent this one. This x multiplied by this x is 2x squared. So you will have minus 2 and minus 1. Because if they are negative in the bracket, they have to be positive as an answer. So that is how you give your answer. Because the calculator using the quadratic formula has given you this, you just put it here and you are done. Okay? Yes. Now let's continue with our paper. I hope you understand everything I just said. Don't forget to like, comment, and subscribe to the channel, and give us what your thoughts are. So we are going to do 1.1.4. We have 3x plus 2 minus 3x not 2. Here it's 3. This one is 2 equals to 486. Now the exponential rule says when the bases are the same, we add the exponents. So we assume that's what happened here and here to get here. So we'll say 3x multiplied by 3 to the power of 3 minus 3x multiplied by 3 to the power of 2. Even if this, if here we had maybe -2, this will be a negative exponent. But because it's a positive one, we were so you just leave it like that. Here is 2 equals to 486. So guys, these are the same. That's why the exponents were added. Okay, do not confuse yourself in any way. Maths is easy. So we have 3 here and 3 to the power of x that side. So that is a common factor. So 3 to the power of x, because it's there this side and it's there that side, we will take it outside. This is grade 10 maths. And now we will have 3 to the power of 3 minus, because of this side. If it was addition, you will add, but it's subtraction, so you'll subtract. And then we'll have 3 to the power of 2. And that will equal 486. Just like that, okay? Now here we are. So what do we do when we are here? We have 3x. We put 3 to the power of 3 to the calculator. 3 to the power of 3, and that will give you 27. 3 to the power of 2, that will give you 9. So 27 minus 9, that will give us an 18. Oh, let me just do it for some of you who are really struggling with math. That will be 21, not 21, 27 minus 9 equals to 486. And then 3 to the power of x equals to 80 times 18 equals to 486. So what happens here is that you will do the next step is to divide both sides by 18 to get rid of it. So this will cancel this, and then 3 to the power of x will equal 486 divided by 18. That will give us 27. Now what needs to happen, guys, is that when you have things like this, anything this side to the power of x, it means you have to write this 27 as a 3. This one, you have to look and write this bigger number as this one. Okay, so we can have 3 to the power of x, and then 3, how to write 3 as a 27, we will say 3 to the power of 3. Just go into a calculator and say 3 to the power of 2, 3 to the power of 1, 3 to the power of 4. Just find a number that you have this side. So we have 3, so we will have x equals to 3. We just take those exponents because the bases are the same. Okay, and that's how we do that one. So here we are on 1.2. Whenever we see this, you have been given functions. Okay, so they have throw in functions in your paper 1. So, in your question 1, so f at x is the same as y. Okay, f at x is the same as saying y equals to. When you say f at x equals to is the same as saying y equals to x squared plus 3x minus 4. So y and f at x are the same thing. Okay, so they say solve for x if f at x is equals to 0, you know that to find y, we let x to be 0, right? And then for us to find x, we let y be 0. So we are trying to solve for x, so y will be 0 plus x squared plus 3x minus 4. So that's how we'll, so this is how we will solve for this one. You say you replace y with 0, which is y, it's f at x, and you'll be solving for x. So they say solve for x. So whenever you solve for x, y has to be 0. Whenever you solve for y, x has to be 0. Okay, if they say find f at x, find y-intercept, sorry, x has to be 0. With functions, right? Because we have entered the functions world. So 0 equals to, what are the multiples of 4, guys? Multiples of 4 that when added, they will give you a 3. That's how you factorize without using the quadratic equation. But I say if you struggle, always use quadratic equation. Don't do that to yourself. It's not worth it. So you still have 2 brackets because of this. 2 brackets has to be there. And then what are the multiples of 4? It's 4 times 1. They will still give you 4, right? And yeah, so they will still give you 4. So we will have, it's 4 and 1. But it needs to be a negative 4, right? So when we put 1 as a negative, 4 times negative 1 gives us negative 4. So this one will be like that. And this one will be like that. You can use a quadratic equation where you'll get that x equals to negative 4 and x equals to 1. So you just change the sign. The 4 becomes positive, it's plus 4. And then this becomes negative in the brackets. And that is how you do it. So we have solved for x for 1.2.1. And then solve for x if f at x is less than 0. This means 1 is less than 2. Okay, that's how you read inequalities, or 2 is greater than 1. So if f at x, solve for x if f at x is less than 0, that is inequality. So 0 is so we will have x squared plus 3x minus 4 is less than 0. Okay, so that is how we do it. And then you will say, you will factorize, put in your quadratic formula, then we'll have x here, and so you'll find that x equals to negative 4 as we have said, and x equals to 1. So it's plus 4 is the same as that one that we just did, is minus 1. And then you draw this, you say 1 here, the positive 1, and then the negative 4 this side, and then you do this. And then you say x is the element of a real number from negative 4 to 1. So this is the final answer. You've gotten your 2x values. So the other one is negative 4. You can even say this. So x is an element of a real number from negative 4 to 1. Okay, to positive 1. Or you can say that f at x is less than 0 when negative 4 is less than x and x is less than 1. That's where f at x is less than 0. Okay, when negative 4 is less than x, then f at x is less than 0, or when x is less than 1, then f at x is less than 0. Okay, yes, if you understand this ones, use it. If you don't, use this one. Easy busy works all the time. So we are at 1.2.3. Determine the x value for which f at x's first derivative, that thing there is first derivative, is greater or equals to 0. So we will say we have x squared plus 3x. They've thrown in some calculus as well. So I hope you know how to derive. When we derive, we say this exponent multiply this number here. So we having 2 multiplied by 1, and that is 2, and then this 2 minus 1, so that will just be x to the power of 1. So we don't have to write the 1. And then we say this 1 multiplied by 3 is 3, and then we have to minus 1, so this will be 0. And then we don't have the rest of that. I hope you know your calculus and you know how to derive. So after deriving, we'll have 2x plus 3 is greater or equals to 0. So we have 2x equals to negative 3. The 3 goes this side. We're solving for x. We divide by 2 to get rid of it. Then x equals to negative 3 over 2. And we have determined the x value for which f's first derivative is greater or equals to 0. So you see, in question 1, they can bring in functions or your calculus. So you must know your story, guys. So let's solve for x. And we are going to use the substitution method. I find it as the easy. You just have to make x or y the subject of the formula. You need to have x equals to or y equals to. And we do not have to do any work, for in this question, they give us x equals to 2y. So I will show you the memo on how you have to write it. But here we're just going to get straight into it. Because x equals to 2y. So where we see x, we put in 2. We'll use this equation. Wherever we see x, we put 2y. So we have x squared minus 5xy equals to negative 24. So we will have 2y squared minus 5y 2y. I may do it like this for each to be easy. It's still the same thing. And then it's equals to negative 24. So here, this exponent 2 will multiply by the exponent there. Okay? So we will have 2 to the power of 2, and that is 4. And then y, the exponent 1 of y multiplied by this one, and that will give us y squared minus 5 multiplied by 2, that will give us negative 10. Y multiplied by y, that will give us y squared equals to negative 24. And then we will have 4y multiplied by minus 10y, because they are like terms. This and this are the same. So that's what makes them like terms. So we'll have negative 6y equals to negative 24. Okay, so while we are here, we need to get rid of the 6. So negative 6y equals negative 24. We divide by negative 6y. We divide by negative 6. So this will cancel. and the negativity as well. We don't need the negativity. So we will just say y equals to negative 24 divided by negative 6. This will cancel, and then we will have 4 as the answer. And then we have y squared. Sorry, we left out the squared, and because of that, to get rid of this, we will have to use a square root. Remember, to get rid of a square root, we use this. So we'll say y squared square root equals to root 4. So this will cancel, and then y equals to 2. And then you found your y value, just like that. Now let's try to find our x value. So y equals to 2. So x equals to 2 into 2. This one. You just substitute the 2, then x equals to 4. So x equals to 4, or x equals to negative 4, just like y equals to negative 2, or y equals to 2, because of what? The root 4. So the 2 becomes negative or positive. So we have 2 x values and 2 y values. So this is how you will be marked on the memo. You will be marked for the 2 x values, and this is how they will mark you. So this is how you should do your work. And then this is how they will mark you. Or you can use the K method. And this is how you will be marked. This is how you will be marked. And this is how you will be marked. You see the negative 4 and 1. Guys, that is the easiest thing. If you do it like that, you understand that part, then you will never stop losing out on this marks. Yeah, let's go to question 2. So here we are. Given the finite arithmetic sequence, arithmetic and linear patterns for grade 10 are the same thing, okay? So if you don't know arithmetic, go and do linear, and you will find that they are the same. It's just that in grade 12, you now have to calculate the sum of arithmetic sequence, but in grade 10, you just do the nth term. Yeah. So we have 5, 1, and negative 3. Write down the fourth term of the sequence. So we have 5, we have 1, and we have negative 3. So 1 minus 5, that gives us negative 4. Negative 3 minus 1, that gives us negative 4 as well. So the common difference, which is D, equals to negative 4. So whenever, guys, you see arithmetic in your formula sheet, whenever you see arithmetic, this is where you play it. Did they give us the one for arithmetic? They only gave us, let's see, they only give us, this one is for the sum of arithmetic. They didn't give us that one that we calculate the nth term here, meaning you should know it. Let me see. No, it's not there. Let me check. No, it's here. This one. So arithmetic, da and da. arithmetic sequence. We are going to play them. They even put them together nicely for you guys. How cute. So it's Tn equals to a plus n minus 1 into d. A is the first term of the sequence, so Tn, sorry, I'm going ahead of myself. So we need to calculate the fourth term of the sequence. So for the fourth term of the sequence, we will say -4, that is the common difference, plus the -3, which is this one. And then we'll find out that the fourth term of the sequence is -7. That is the fourth term. So calculate the number of terms in the sequence. How many in this sequence? How many number of terms do we have? So they have given us that the sequence ends with -87. There is nothing, and after that, if there is nothing like this, then this means that this sequence ends with -87. So we are going to use Tn equals to a plus n minus 1 into d. Okay, the Tn is the term number, and then for the n, the Tn represent the 5, and then the n represent the position of the 5, which is 1. Okay, so that is what you need to put in mind always. So we will have -87 equals to, the first number is 5, so a equals to 5 plus n minus 1, and the common difference is -4. That is the constant common difference. So we have -87 equals to 5 plus -4 times n, that will be a -4n, and then -1 times -4, and that will be plus 4. That will be plus 4. So we will have the -87 equals to 5 plus 4, that will be -4n plus 9. So we'll have -87 minus the 9 equals to -4n. Anyway, I've made a mistake. Let's look at the mistake. Yeah, here is the mistake. No, it's still fine, still fine. It's still fine. We added the 5 and the 4 because they're both positive, so we take them this side. So now it's -9 here. That will give us -96 equals to -4n, and then we divide by -4 to get rid of it, and then n equals to 24. So meaning we have 24 numbers or positions in this pattern. So -87 is term number 24. So calculate the sum of all negative numbers. All negative numbers. So we have 2 positive numbers out of the 22. So we say 22. No, we have 2 positive numbers out of the 24 on the series. So we have 24 minus 2, and that will give us 22. So we have 22 negative numbers, but they are saying the sum. The sum is like saying -3 plus -7 plus all the numbers in this sequence. It's like adding them. Okay, that is the sum. So the sum is like it's adding them. So because we don't have time to be adding all those numbers, we use equals to n over 2 into a plus tn. Yes. So what we are going to do, we say s, the n, 22 number. In the sequence we have 22 over 2. The first number in the negative series is 3 plus the last number is negative 87. So s equals to negative 990. So the sum of the negative numbers is negative 990. Yeah. So we will do 2.4. Consider the sequence 5, 1, negative 3, 80, and then it ends at negative 4,187. Determine the number of the term in this sequence that will be exactly divisible by 5. So we have 5, and here we have 1. Here we have 1 and 3. So meaning we're going to have 15. So we'll have 5, 15. In this sequence we will have 35. So those are negative until here negative 4187. So we need to calculate determine the number of terms in this sequence that will be equal to that. All right, so here we'll say tn equals to a plus n minus 1 d. It's still an arithmetic, so tn equals to 15 first the first term of the sequence. No, we'll do it like this. The first one is 5 plus n minus 1 into negative 20. Negative 15 minus 5 is negative 20. Negative 35 minus 5 minus 15, sorry, it's still negative 35 minus negative 15 will give us negative 20. So and then you will have negative 15 minus negative 5. So your difference will be 20. So tn negative 20 equals to minus 20n plus 20, this ones, and then this is 20, and then we'll say tn equals to negative 20n plus 25. Okay, and then the sequence end at 1 negative the sequence. Now we have found the formula for the nth term. We can look at that. So we'll have negative 4175 equals to negative 20n plus 25. We're solving for n. So negative 4175 minus 25 equals to negative 20n, and that is 4200 equals to negative 20n divided by 20 divided by, so we'll just have 4200 divided by negative 20 equals to negative 20n divided by negative 20, so that will cancel, and then you'll find out that n equals to 210. So when we end at negative 4175, then we'll have 210 terms that are divided by 15. So we are done with question 2. Please guys, don't forget to like, comment and subscribe. So we are given this, and the first thing, calculate the value of x. The first 4 terms of a quadratic has the second same difference, okay, not the first, like arithmetic and linear. So with a quadratic, did it in grade 11, second first difference, okay, that is where so you had to find a, b and c. So we have negative 1 x 3, and then we have x plus 8. So here in between we have x minus negative 1, and this, they will become positive, so we have x plus 1 there, and then between these two we have 3 minus x, and then between this one we have x plus 8 minus 3, so that is x plus 5, and then we will have the second difference, the second constant difference. So x plus 1 has to minus x plus 1. Oh no, we have this one minus, it's the second one minus the first one, okay, to get the difference. So here we will have 3 minus x plus 1. So 3, this will end up being a negative x and a negative 1. So 3 minus 1, that is a 2, and then we have here negative x minus the x, it's like saying negative 1 minus 1, and that will give us a negative 2x. So here everything will be 2 minus 2x, and then we'll have x plus 5 minus 3 minus x. So we'll have x minus x minus negative x, that will also be 2x, negative 2x, and then 5 minus 3, that will be 2. So you find out that you see 2 minus 2x, okay. So the second constant difference is there. Now what we will do, we will say 2 minus 2x equals to 2 minus 2x. So it's 2 minus 2, this 2 will come this side, and then we still have the minus 2 plus 2, okay. So negative 2 plus 2, so no, sorry guys, I made a mistake with the signs somewhere here. This is 2, so it's negative 2x plus the 2 equals to 2x. This side is 2x, yeah, plus 2. So because it will be x plus 5, and then we will also have 3 minus x. So the x of the 3 plus 5 is positive, and then the x minus negative. So they'll just give us, they will end up, that x will end up being positive. Yes. So this is what we have. So negative 2x minus 2x equals to 2 minus 2. So we'll have 4x equals to 0. Divide by 4. Then x equals to 0. So our x value is 0. So if x equals to 0, determine the position of the first term in the quadratic number pattern for which the sum of the first n first differences will be greater than 250. So here in this quadratic, so you have, if x is 0, you have to determine the position of the first term in the quadratic number pattern for which the sum of the first n first differences will be greater than 250. So we have the sum. So we'll have Sn equals to n over 2 into 2a plus n minus 1 into d. So Sn equals to n over 2. A is 1 plus n minus 1, and the difference is 2. So we asked to look for the second difference, guys. So the second difference, the first number is 1, the second one is 3, and the third one is 3. So we have to determine the position of the first term in the quadratic number pattern for which the sum of the first difference will be greater than 250. Okay. So we did another pattern using the second difference. We have negative 1, right? And 0, because x is 0. And then 3. And then 0 plus 8. So 0 minus 1 minus, in fact, it's 0 minus negative 1. That gives us 1. And then 3 minus 0 is 3. 0 plus 8 minus 3, that gives us 5. So those are the differences that I'm talking about. And now we have to solve for n. So Sn equals to n over 2 multiplied by 1. That gives us 2 plus n minus 1 into 2. So we use this formula for the second difference pattern, right? So that pattern, we start a new pattern, so it's like we are starting an arithmetic. Okay, that's why we're using this formula. It's just important for you to understand the question. Equals to n over 2 into 2 plus 2 minus multiplied by n, that is 2n multiplied by 2, like that. So we will have n over 2 over 2n inside, like that. And then we will cross multiply this, n over 2 multiplied by 2n over 1. So this will be 2n squared over 2. So 2 divided by 2, we'll have that Sn equals to n squared. So the Sn will be the 250 less than n squared. And then what we do is say 250 we square root it's more than, it has to be greater than, yeah, n squared. So we square root, so square root of that is that n equals to 15,8. So that is 5 root 10. 3.2 says rectangles of width 1 centimeters are drawn from the edge of a sheet of paper that is 30 centimeters long that are in a 1 centimeter gap between one rectangle and the next. So the rectangles are the ones that are gray shaded, and we have a 1 centimeter difference between the different rectangles. Okay. So the length of the first rectangle is 21 centimeter, and the length of each successive rectangle is 85% of the length of the previous rectangle. Until there are rectangles drawn along the entire length of AD, each rectangle is colored gray. So this rectangle is 21 centimeter. This one is 85% of 21 centimeter. This one is 21 multiplied by 85% squared. So we are minusing the previous ones, just like that. So when you say 85 divided by 100, that is the same, that is a percentage. Okay, 85 divided by 100 is a percentage, so that gives us 0. 85 divided by 100 gives us 0.85. Okay, so we will answer 3.2.1. Calculate the length of the 10th rectangle. So the 10th rectangle, and then in this sequence we have 21 into 0.85, that is the second one, 21 into 0.85 squared, and so forth. So because we are multiplying to get the next one, obviously that is a geometric. So T10 equals to A, which is 21. Common difference, we are doing the 0.85, multiplying by 0.85, and then 10 minus 1, and that is 9. So you put this in the calculator, is 4.86 centimeter. So we've just did 3.2.1. This is arithmetic, how to calculate the nth term. And then 3.2.2 says calculate the percentage of paper that is colored gray. Well, that is 50%. Let's look at it together. Here this thing is 30 kilometers long, and all the shapes are 1 centimeter, and there's 1 centimeter difference. So it means it's 15 for the rectangles and 15 for the space. Okay, and then 15 for the empty spaces. So we have to calculate the percentage of the paper that is colored gray. So how we do that? We firstly have to do this. Sn equals to a 1 minus equals to 1 minus r. So S15 equals to 21 is a 1 minus 0.85 to the 15 over 1 minus 0.85. So the sum of this will be 127.77. So that is the sum of this arithmetic sequence. And so we will say, let's find the area. Well, here is 30 and at the bottom is 21. So we will say 30 multiplied by 21, that will give us 630. So the 127.77 over 630 multiplied by 100 will give us let's do it, let me do it first. 127.77 over 630 multiplied by 100, and that will give us 20.28. So these are one of those tricky questions, but if you struggle a lot with maths, just don't stress yourself about them a lot. Understand the question and you will get an idea of what is needed. We are now in question 4, and let's look at, sketched below is the graph of h at x equals to a to the power of x. A is greater than 0. R is the y-intercept of h. The points of P is 2 and 9. The points of Q is B and 1 over 8 lie on H. So this is basically the graph. As you can see, that is your graph, is an exponential graph. So the first one says, write down the equation of the asymptotes. Now let's look. Asymptotes are those dotted lines that go something like this. And here we don't have it, so y equals to 0. That is the equation of the asymptote. With an exponential graph, we can only have the asymptote cutting the x-axis, okay? Not the cutting the y-axis, sorry, not the x-axis. So we don't have that dotted line. So x is equals to 0. That is the equation of the asymptote for a y graph. Is x equals to something, is y equals to something. Determine the coordinates of r. When you see one mark and you're told to tell the coordinates, guys, you're not going to calculate. You're just going to look at the graph and you will know. So the coordinates of r are here. So that is 1. Q is a bit lower than r, so rx is 0. So let's say 1 over 81, yeah, it's 0.01. So meaning that the coordinates of r will be 0 and 1. So we've determined that for 1 mark. You don't have to calculate them, okay? That's how you do that. And then 4.3, calculate the value of a. the value of a needs to be calculated. So here is the h at x equals to a, like that. So we're going to look for any values in the graph to substitute. 9 equals to y and 2 equals to x. So we'll have 9 equals to a. So we need to solve for a, 9. So we're going to square root to get rid of that. And then 3 equals to a. So meaning a equals to 3. So meaning the new equation here is h at x equals to 3x. 3 to the power of x. Yes, that is how you will do it, guys. Functions are not hard. I have a functions playlist that I did, and if you're finding it hard, please check that out. Functions are your best friend. Very easy. D is a point such that DQ is parallel to the y-axis. Where is DQ? That line parallel to the y-axis, and PD is parallel to the x-axis. That top one. Calculate the length of DP. So we have to calculate the length of from D to P. So we're going to use the x values to calculate this length. Okay, so DP, which is this one, is equals to 2 minus B. If you can see, D y-intercept is 9, and then the x1 is B because we don't know this one, so it's cutting like that. Okay, so it's B and 9. So DP the length of that one is 2 minus B. Okay, so we have to calculate the value of B. B is what? Is x value, right? So we need to look for the x value. So we'll just use y equals to, we use what we have to calculate this. The y value is 1. So when y is 1 over 81, how much is x? That's what we're looking, so we can find this B. That's how you calculate it. So can you write 3 as 81? Sure, you can. So that will be 1 over 3 to the power of 4 equals to 3x. So remember, when we have negative exponent, is we write it like this, exponential rules. Okay, very important that you know them. So that will be 1, that will be 3 to the power of negative 4 equals to, like that. So the bases are the same, so negative 4 equals to x. So B equals to negative 4. So DP equals to 2 minus negative 4. So DP equals to 6 units. So determine the values of k for which the equation h at x plus 2 plus k equals to 0 will have roots that are less than. So that will be h at x plus 2 plus k equals to 0. Then you just say h at x plus 2 equals to negative k. So meaning h equals to k, and then x plus 2 equals to k. So x equals to k minus 2. So what we are going to do here, we're going to say we'll have roots that is less than -6. So when 0 is less than k and k is less than 1/81, then the values of k for which the equation h at x plus 2 will have a root that is less than -6. That is the answer for 4.5. 4.4. So we can look at 4.5. So this will be our last question for part A, guys. We'll continue with question 6 in the next part. Don't forget to like, comment, and subscribe to the channel. -x² plus 4x minus 3. That is a parabola. So this is a parabola. This is a hyperbola. Okay. When you see anything like this, just know it's a parabola. And then let's see what they want. Show the coordinates of B are 2 and 0. Where is B? There. And what is that? Is the turning point of the parabola. So the parabola is given in a form of f at x equals to -x² plus 4x minus 3. So we use the formula b over 2a for the turning point. So that is the x-intercept. So x equals to negative b over 2a. So x equals to, this is b, that will be -4 over 2 into -1. So this is -1. And then the x coordinates of the turning point will be 2. And then we take this 2. If x is 2, how much will be y? So that is where we will say 0. That's where we'll say y equals to -2 squared plus 4 into 2 minus 3. Substitute in the original equation, and then x is 1. So the coordinates of B will be 2 and 1. And then 5.2, write down the range of f. So for the range of f, range is the y values and domain is the x values. So let's look at this. F, so this is the f at x, the parabola. So the turning points here are 2 and 1. So range, y is the element of is that range, y is the element of a real number. From here, what is here? The y value there, what is it? Is this is from down here going high. If it's like this, you start from -infinity until where it stops there, if it's a parabola. So that will be -infinity until 1. Okay, so that will be the range. But if the parabola is like this, it will be from this point going to +infinity. But if it's facing down, you start with -infinity for the y. So the y represent how low or how high. Okay, and then for range, and then the domain is how far left or how far right. So that is how you answer that question. 5.3, for which values of x is g at x greater or equals to 0? When is x greater or equals to 0, guys? Is when x we can even write it like this: from negative infinity 1. Yeah, we'll say x is the element of a real number. This is where, and to positive infinity. So this is for the x, and this is for the y. Or we can say when x is less than or equals to -1, or when x is greater than 2. So the values of x will be greater or equals to 0 here. Just use your domain, your turning points. Determine the equation of the vertical asymptote of the graph of h if GH is equals to. So guys, I feel like this video is too long. Let's continue on the next video next week, where we will be completing question 5 and the rest of the question paper. Thank you very much for watching. Until the next video.